Yeah, Abhishek.
Yes, sir. I get confused between the combination and permutation concept. Like सिलेक्शन जैसे हम परमुटेशन में सिलेक्शन करते हैं, और कॉम्बिनेशन में जैसे कॉम्बिनेशन बनाते हैं, उनमें कंफ्यूजन काफी होती है. समटाइम्स लाइक इफ आई सी अ क्वेश्चन फ्रेश, मुझे नहीं पता वो परमुटेशन का कॉम्बिनेशन का है, तो उसमें थोड़ा सा ऐसे होता है कि आई गो फॉर परमुटेशन, की इसे परमुटेशन से सॉल्व करना है, इसे कॉम्बिनेशन से सॉल्व करना है.
I see.
यस.
I see.
बट समटाइम्स आई डू मैंने कुछ क्वेश्चंस मैन्युअली भी करता हूँ. लाइक आई स्टार्ट काउंटिंग, सिंपल एक ही काउंट करने लग गए. लाइक इफ देयर दिस दीज मेनी कलर्स, हाउ मेनी कॉम्बिनेशंस कैन बी मेड, तो मैं कभी कभार काउंटिंग भी करता हूँ. दैट आई फाउंड अ लिटिल थोड़ा सा इजी, क्योंकि वो सिंपल काउंटिंग है.
Right.
बट बट इन एग्जाम यू डोंट हैव दैट मच टाइम कि आप काउंट करने बैठे. अगर
Yeah.
इफ अगर इफ अगर कम में जैसे कलर्स, जैसे 4 या 3 कलर्स की बात हो रही है, तब तो इट्स इजी. इफ
Yeah.
इट्स लाइक 10 कलर्स, देन यू कांट काउंट, तो फिर वो वहां प्रॉब्लम फेस करते हो.
Yeah. Yeah.
तो उसमें सिलेक्शन जैसे परमुटेशन एंड कॉम्बिनेशन के कॉन्सेप्ट में कंफ्यूजन, आई फील कंफ्यूजन.
Okay.
यस
Right.
सर.
Thank you.
यस.
Yeah. Priya, you wanted to share?
So actually, it's not relevant to this question. I have something else to talk about on the group. One of them was saying that coordinate geometry is part of algebra, which was very confusing in my mind. So I wanted to clarify this, or maybe you can clarify this, whether geometry or coordinate geometry is part of the syllabus or not. Because from what I read, I don't think it is. Algebra में तो नहीं आता है, but I could be wrong. So
Coordinate geometry is a part of GMAT focus.
is it?
Yeah.
Okay.
Geometry is not a part of GMAT focus.
So this would come under which section generally? Because
Whatever section it comes under, it is a part of GMAT focus. And yeah, geometry is not.
अच्छा ठीक है. Okay. To this relevant to this subject, कभी कभी PNC के questions में सब probability भी mix होता है.
नहीं होता. हाँ, probability में PNC concepts use होते हैं. That's fine. तो
मैं
permutation
वहाँ पे
probability mix नहीं होता है, but probability में permutation combination heavily use होते हैं. Yeah.
Okay, तो मैं वहाँ पे confuse होती हूँ. I don't know if that is something that we are going to talk about in this session, but ये mixing of the two concepts में थोड़ा मेरे को confusion रहता है.
Yeah.
So that is one of my pain areas.
I see.
I agree. I also get confused there. But in permutation and combination, the main error I face is when I get a question on permutation and combination in like a different wording. So for example, I'm used to solving and or type के permutation combination questions, or the ones that you've solved previously. उस type का कोई और आ जाए, तो I'm able to comprehend what to use and like which format to calculate in. But then if there's something like totally in a new wording, which usually comes in GMAT exams, for example, there's like some network diagram wala thing, and there's just new things which keep coming on. Sometimes I'm not able to articulate it well, but that I get very confused in कि क्या use करना है based on the wording. If it's a new wording or a question type which I haven't seen in permutation combination, I get very confused during the exam.
Okay. Okay. ठीक है. Yeah, Khushbu.
Yeah, hi CJ. So even I used to have a hard time on PNC during my first attempt, but I have, I had decided that I want to get over with this fear of, whenever these kind of questions used to come, I
Right.
used to I used to feel that I'm not able to do it, right? So for this thing, I constantly saw a lot of question. I gave maybe a week for this topic, and then I realized that it's all about if you're able to visualize number of cases, and definitely the difference between permutation and combination, it actually helped me So my major of the problems are solved. Just that whenever there are a lot of cases on maybe 700 plus questions, so therein I face in timing. Like I can solve that question in more than 2 minutes, but my real challenge lies in that 2 minute thing for very hard questions. But yes, even I used to have a lot of pain on these kind of questions. But yes, visualization, and then differentiation between permutation and because I used to, whatever I am visualizing, I used to write it constantly even if I am taking a lot of time. So for below 700 I was able to get the grip. But yes, for some of the question like cubes or some where there are like maybe more cases, so maybe I am using the longer pattern of solving, so that is my challenge. I need to reduce time.
Right, right. Okay. Shivangi?
Sir, there are some questions जिसमें total में से minus करके you find out the result, and somehow I go with the longer method of calculating, and whenever I see the solution it's usually the shorter method, so I don't understand when in which questions do you exactly use those. And one thing that Abhishek also covered, where to exactly use permutation and where to exactly use combination. That was it.
Hmm. Okay. ठीक है. Or anybody else wants to share कि क्या problem आती है in this concept of permutation combination? Yeah, Krishna.
One more thing I would like to add. I used to initially, when I used to solve these kind of questions, I used to mug up formulas. Okay, for this NCR, NPR, but at the end it's same only. We just need to make sure that whenever we are doing selection or there is a permutation, so we can calculate those formula in a single format, so that constantly reminding yourself that you need to apply a formula, it doesn't help on harder question. So this was one of the thing which I used to do it, but then I stopped doing it.
Right, right. हम्म. ठीक है, तो एक तो प्रॉब्लम परमुटेशन और कॉम्बिनेशन के जो बीच का डाउट है कि whether permutation should be used, whether the order matters or the order doesn't matter. And then so one is new contexts में अगर different kinds of contexts in permutation combination, I think Kansha was talking about, that becomes confusing. And then we have Shivangi was talking about some questions can be solved by 1 minus some cases, so she ends up taking the longer way. So my concern is, should I go with the basics, or are the basics in place and then you have trouble just applying the basics or solving more medium to hard questions? Where do you stand? Yeah, Abhishek.
Yes, sir. So I feel I know a little basics, तो थोड़े बहुत पता है, basics पता है, but I find applying it. तो application में मुझे problem आती है. मेरे से क्या कहते हैं, वही जो सेम प्रॉब्लम आपसे बताई थी कि कंफ्यूजन होती है कि परमुटेशन करना है कि कॉम्बिनेशन करना है, मतलब.
I see.
या
Others, same problem.
So I think we can do medium level questions to start off with, basics in place, but we can go a little higher than that, higher than basics, but not like 700 plus questions.
हम्म, ठीक है,
Yes, sir, I agree with Riya.
I see. ठीक है, so let me start with this one. So let me start with a simple one. I'll add complexity to it. Uh, hmm, you can see my screen. So you
Yes.
can share your answers in the chat window as a direct message to me. Of course, you don't need to calculate the exact number. You can just share in terms of this factorial divided by whatever. Hmm. So yeah, everyone who uh, has submitted the same answer, which is correct. So let me give you follow-up question on this. So we'll go one by one. So how many of these arrangements do the words start with P? So you can copy paste also if you want to keep most of the things same. You can just copy your message, paste, and then you can change the relevant part. Only 2 responses so far. Okay, what about others? So yeah, so let me just share the answers. So yeah, the original answer is, so there are 12, sorry, there are 12 letters. Okay. So 12 factorial, and there are 4 E's, so 4 common, 4 factorial, 3 N's, 3 factorials, and 2 D's, 2 factorial. If you start with P, then essentially that P is fixed. You have 11 remaining letters that you can change. So it just becomes remaining everything is same. So now let's look at the second one. So now we are looking at the arrangements in which the vowels occur together. Now I'm having different answers. So this is first, this is original. And now we are looking at the second one. So answers for the second one. Okay, I'll give you 1 more minute. Just try to solve the second one. Okay, some variety. So let me start with the first one. So Khushbu gave the answer first. So Khushbu, how did you go about it?
Okay. So basically, we need to do arrangement where vowels always occur together.
Correct.
So what I did, I bifurcated all the letters in two segment, one with vowels, another with consonant. ठीक है? So
Right.
that is one thing. So vowels are like there are 5 vowels. Okay. I just mentioned everything here so that it becomes easy. How many are repeating? I, E, yeah. And other
Oh,
are N, D, P, and D, and C.
1 second. N, D, P, N, D, N, C.
Okay. So these are 2 sets. So we
Right.
need to do arrangement here. So first, what we should do, we should see that vowels will always occur together. So either vowels can come first or maybe after consonant, right? So these are 2 factorial arrangement between these two.
They can come first or they can come after consonants.
Yeah, this is between the bundle arrangement. So that is one.
So can
Two
they
for,
come in the middle?
sorry.
Can they come in the middle of consonants? For example, N, I, E, 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 T, P, and then whatever.
Yeah,
You're,
yeah, they can come in between as well. So
what you were saying 2 factorial. Yeah. I think you were thinking that either the entire thing will come before this or will after this.
okay, so I think I made a mistake here, maybe. Okay, so we can do one thing. We'll start with vowel arrangement first. Okay, so that is 5 factorial divided by 4 factorial. That is one thing. Okay, so here the second one would be the consonant separately. 7 factorial divided by 2 factorial and 3 factorial.
Right.
Okay, I think I made mistake in that 2 factorial part. So I'm just thinking that if they come, can't it be like the whole into 2 factorial?
This into 2 factorials.
Uh-huh.
So why are you doing 2 factorial?
Because we have done arrangement separately, right? We need to do together as well. So whenever they will be when we are combining every all the letters, right? So I'm just thinking that this two is right or no, because that combination is sorry that permutation is also possible where they can come in between as well.
Yeah.
Yeah.
Okay. So this is wrong. So
Mm-hmm.
the incorrect assumption is that you are taking that. So there are only two kinds of mistakes. Two kinds of mistakes we can make. We can overcount or undercount. So here it's an undercounting because you are assuming कि या तो वो पहले आएगा वो बाद में आएगा.
Mm-hmm.
Okay.
Okay, I get it. I get it. Sorry. So in place of 2 factorial, we are supposed to do this 7 plus 8 factorial, because and then divided by uh, 3 factorial, 2 factorial.
Think about it. No hurries. Okay.
Okay.
You take your time. Okay. Uh, and then I have Ria here. Ria,
Yes, sir.
how did you do it?
Sir, I took the vowels as one entity, keeping it
ठीक है.
as one,
ठीक है.
and counting the rest 7, and then together it's 8 factorial
ठीक है.
divided by
तो
the
7 consonants हो गए और 8
7 consonants और ये
एक.
एक पूरा, हाँ
So
इसको
total
साथ
we
ले
have
लो,
8 items.
हाँ divided by the repetitions, that is 3 factorial, 2 factorial, and मैंने साथ में 4 factorial भी लिखा था IEEE का, which I'm not sure. तो मुझे वो गड़बड़ लग रही है. I'm not sure about that.
तो वो तो एक एंटिटी है ना, वो तो एक ही है, उसका कोई रेपिटेशन थोड़ी ना हो रहा है आई 4 टाइम्स ए का. तो वाई आर यू डूइंग बाय 4 फैक्टोरियल?
अपने में उसका अरेंजमेंट भी तो हो सकता है सर. आई
उसको तो हमने एक ही काउंट किया.
किया एक ही काउंट है, बट
तो उसके अरेंजमेंट्स हो सकते हैं, वो तो फिर मल्टीप्लाई होंगे ना, तो आप तो डिवाइड कर रहे हो 4 फैक्टोरियल्स. क्या करेंगे यहाँ पे?
yeah, no, I'm not sure, sir. Not clear whether it's divide or multiply.
हम्म. तो ये 8 फैक्टोरियल किस केस में है?
Is when पूरे वॉवल को
एंटिटी
एक
है ना,
यूनिट. हाँ.
ये एक एंटिटी है,
हाँ.
राइट? तो लेट्स से सिर्फ यही है आई 4 टाइम्स ई. इस केस में यू हैव 8 फैक्टोरियल बाय 3 फैक्टोरियल 2 फैक्टोरियल.
हम्म.
इफ यू डिवाइड बाय 4 फैक्टोरियल तो कम क्यों हो रहे हैं केसेस? ये तो हमारे लिए एक ही था,
हम्म.
राइट? इसको तो हमने अलग से काउंट 5 तो माना ही नहीं है इसको कभी भी हमने.
हम्म.
इन योर केस वी आर जस्ट काउंटिंग एट वंस, राइट? नो.
हम्म.
तो इट्स लाइक कि हम, ये तो सब है ही है एन डी पर, और जो भी है एन टी पी एन डी, और क्या है हमारा
सी.
एन सी. उसके अलावा लेट्स से हमने एक्स ये मान लिया, वो एक्स तो एक ही आ रहा है, एसेंशली इसकी बात कर रहे हैं ना हम.
राइट.
जस्ट 8 फैक्टोरियल बाय 3 फैक्टोरियल इंटू 2 फैक्टोरियल, राइट?
या.
So why will you divide it by 4 factorial? No?
या.
Yeah, is not very clear.
कि
Hmm?
कि हम कौन से केस में इसको as divide by 4 factorial when we are counting it as individual entities.
हाँ, तब तो रेपिटेशन है ना, तब तो 4 ईज
Repetition
आ
है.
रहे हैं, तब तो
हम्म.
हाँ. पर अब तो आपने इसको एक एलिमेंट मान, ये अपने आप में एक एलिमेंट तो है कि अगर एक और आई 4 टाइम्स ही होता
हम्म.
तो उसे डिवाइड करते ना हम, राइट?
या.
तो इसको अगर हमें एक्स मान रहे हैं तो एक्स तो एक ही है हमारे पास.
हाँ, अगर x होता तब.
हाँ, अगर एक और एक्स होता, करेक्ट,
एक और
तब
x
हम 2
होता.
फैक्टोरियल, तब हम 2 फैक्टोरियल से डिवाइड करते हैं, राइट?
या सर, समझ गए. ठीक है.
तो यहाँ पे सिर्फ ये एक ही है, इट कैन ओनली बी आई 4 टाइम्स ई. Or it can be something else also.
Whatever if it is also something else, it's the question is that the vowels are together.
हाँ, तो
So वो
वो
इसका
together,
internal arrangement कुछ भी हो, they are all together only.
हाँ,
हाँ.
तो उनके जो डिफरेंट अरेंजमेंट्स हैं उनको काउंट करना है हमें या नहीं करना?
करेंगे ना सर, वो तो कुछ भी हो सकते हैं, तो 4 फैक्टोरियल.
तो वॉवेल्स के अपने कितने अरेंजमेंट्स हो सकते हैं? वुड यू लाइक टू मल्टीप्लाई दैट विद दिस फिगर?
So this will be 5 factorial divided by 4 factorial.
विच इज सिंपली 5, क्योंकि
Yeah.
आई फर्स्ट आ सकता है, सेकंड पे आ सकता है, थर्ड पे आ सकता है, फोर्थ पे आ सकता है, फर्स्ट पे आ
Correct.
सकता है, राइट?
Yeah.
देयर आर
Yeah.
5 possible, which is also same as 5 factorial by 4 factorial, but that sort of eliminates intuition. If you just say 5, then you know कि ये 5 केस आ गए हैं यहाँ पे. Okay, so this will be the answer. ठीक है, again it can also be written as 5 factorial by 4 factorial, which is the same as this. Abhishek, how did you do it?
Sir,
Uh-huh.
I took, sir, मैंने vowels, I took like कि constants, like constants हैं तो for
Components.
them I took 7 factorial.
ठीक है, वो 7 है.
Yes, sir.
7 कॉन्सोनेंट्स हैं, उनको आपस में अरेंज कर सकते हैं. 7
Yes, yes, sir.
divided by 2 factorial into 3 factorial.
Yes, sir.
ठीक है, ये कॉन्सोनेंट्स का हो गया. उसके बाद
Sir, मैंने so then I arranged these vowels के लिए the e के लिए फिर मैंने अलग डिवाइड किया 4 फैक्टोरियल into 4 फैक्टोरियल.
तो पर वो क्यों कर रहे हो, मतलब वो तो वॉवल्स के अलग हैं, तो वॉवल्स का अलग से काउंटिंग कर रहे हो, या अभी इसी में ही सब इकट्ठा ही कर रहे हो, एक ही साथ कर रहे हो सब कुछ?
मैंने एक ही साथ किया था सर.
तो एक ही साथ, तो फिर अगर सब कुछ इकट्ठा ही कर रहे हो तो फिर सिर्फ कॉन्सोनेंट्स का 7 फैक्टोरियल क्यों लिख रहे हो? उसमें वोवल्स कहाँ गए?
राइट सर.
नहीं, अगर डिनोमिनेटर में आप कह रहे हो मैं इकट्ठा ही कर रहा हूँ 3 फैक्टोरियल 3 फैक्टोरियल, तो फिर न्यूमिनेटर में आप इकट्ठा नहीं कर रहे हो, राइट?
राइट. यस सर. तो साथ में
हाँ, तो वो तो एक अलग इनकंसिस्टेंसी है. अगर आप जो भी कर रहे हो कम से कम कंसिस्टेंट तो रहो. कंसिस्टेंट रहने के बाद जो प्रॉब्लम आएगी फिर वो अलग बात है.
ठीक है सर.
या सौम्यदीप, आपने कैसे किया?
So actually, I did also 8 factorial divided by 3 factorial into 2 factorial into 4 factorial. So after your explanation, I got that like the position of pi also can change, which I didn't consider actually. I just took one, मतलब एक ही
उससे तो यहाँ पे सिर्फ 5 से मल्टीप्लाई हो जाएगा बेसिकली.
या तो like 5 factorial I missed it, like जो टोटल vowels का अरेंजमेंट हो सकता था 5 factorial.
वो तो 5 ही होगा एक्चुअली, ई का रेंज.
Yeah,
आपने 4 फैक्टोरियल क्यों डाला हुआ है यहाँ पे?
because of 4 e's.
बट उसको तो आप एक ही एलिमेंट मान रहे हो, क्योंकि 8 फैक्टोरियल कर रहे हो आप. जब आप एक फैक्टोरियल कर रहे हो तो इसका मतलब है आपने उस पूरी एंटिटी को, आई जो भी है वो, उसको एक एंटिटी माना है. सो देयर इज नो रिपीटिशन ऑफ दिस वन एंटिटी.
या बट मैंने सोचा कि लाइक ई का पोजीशंस भी चेंज हो सकता है, सो उस
तब
केस में
मतलब
like, जो डुप्लीकेशंस होगा इन ऑर्डर टू कैंसल आउट दोस डुप्लीकेशंस.
डुप्लीकेशन तो
तो
है ही नहीं, क्योंकि आई 4 टाइम्स ही एक ही केस है आपके लिए, इसी को ही घुमा रहे हो.
या वही मैंने मिस किया.
अगर इसको हम अलग अलग केस मान रहे होते तब अलग बात थी, बट हम तो एक ही केस मान रहे हैं इसको, आई आई 4 टाइम्स ही, राइट?
या गॉट इट.
हम्म. शिवांगी, हाउ डिड यू, अच्छा, शिवांगी, आर यू क्लियर? योर आंसर इज आल्सो डिफरेंट.
Yes, sir.
ओके.
Sir, I changed my answer
ओके.
at that time.
ठीक है. ठीक है, cool है. So everybody clear with the second?
Yes, sir.
ठीक है. So now let's look at the third one. So now we are looking at, and now you can share your answers for third. Some of you have already shared. So yeah, I'm looking for answers for the third one. Yeah. So I think that's an easy one. So if you fix I and P, then essentially you're left with 10 characters. So 10 factorial, and you have some repetitions. So 10 by this. All of you are essentially getting it right. Okay, cool. Let me bring up another question. Okay, it's the one. You have 3 minutes to solve this question. Yeah. So yeah, all of you are getting it right. Yeah. So there are 10 digits and we need to create a 3-digit code. The first number cannot be 0 or 1. So it can be any of the other 8 digits. The second must be 0 or 1. So you have just 2 possibilities. And the second and third cannot be 0 in the same code. So if you have second 0, then third is cannot be 0. Essentially, there are 8 possibilities for the first one, except 0 and 1, the remaining 8. And if the second is, let's say we take second to be 0, then that is just one possibility. And the third one in that case has to be one of the other 9 possibilities, x beyond, right? Non-zero basically. This is the second digit is 0. Or the second digit could be 1 also. In that case, 8 into 1 into. Now the third is open. It can be 0 also, it could be 1 also, it could be any of the 10 digits. So you have these two cases, which is 72, and this is 10. So 80. So overall, if you sum them up, you get 152. Okay. Another way is, of course, what you can do is you can take the second to be all 2 possibilities, 0 or 1. The third one, you take all the 10 possibilities, you get 160. But now you have some cases in which the second and the third both are 0. So you subtract both those cases. So you need to, so the first one can be any digit. The second is 0. The third is also 0. So there is only one case possible for each of these. So you subtract 8 out of 160. So you get 152. Any questions? Any doubts, sir?
No, sir.
Yep. Yeah. Yeah, Khushbu.
CJ, can you go back to previous slide? I think I need clarification for last answer. I think that third one has to be 10 factorial divided by 3 factorial, na, in place of 4.
Right.
Because, oh, I'm sorry. I misread the question. I actually assumed that I and E are fixed that
Okay.
way. Sorry, my bad. My bad.
Any questions? Any doubts in this one? Okay. Let's look at this one. Okay. So Arvind, would you like to share how you did it?
Hey, hi CJ, hi everyone. CJ, so in this case, uh, basically what I did was we have 5 digits, out of which there's a repetition for letter I. So there's one combination we are taking all I mean, there's one combination where we're taking all the digits and trying to see the arrangements. So it will be 5 factorial by 2 factorial. And there's another combination where what we're trying to do is we are taking both i's together. So in this question, what we have been asked to do is we have to ignore this criteria where both the i's are together. So once we subtract that combination, we'll get the number. So 5 factorial by 2 factorial minus 4 factorial by 2 factorial will give us 48.
Sort of by 4 factorial by
2 factorial
by
divided
2
by 2 factorial. Yeah.
by 2 factorial here.
So basically what you are doing here is you are taking digit I as I mean as single digit. So I think what we did earlier as well. So if we have I both i's together, so we are basically trying to arrange these 4 digits. And since within okay, mm, both i's are together, I think we will only take it once. For yeah, just give me a second, see. Yes. No, I think it should be D. I guess it should be D.
Okay. Why?
The reason is here I think you try to arrange I in either ways internally, it will be only giving you one arrangement. So effectively, uh, you are trying to arrange DG. You take both i's and as any other letter, say X as you
There
said,
is no
as you put.
repetition of II. So if you consider II together, this is just one.
Exactly. So this is basically it's a 4 factorial. Don't need to
Yeah.
divide it by any number. I mean, if we had anything else, suppose some other letter, then in that case that was then that we should have considered that part.
Yeah.
So it would be 36.
Right. So the way we do it is total cases minus the cases in which two i's are together. So you get the cases in which two i's are not together. So there is at least one letter between them. So this is 60 minus 24, which is 36.
Right.
Any questions, any doubts here? Yeah, Shivangi.
Sir, even when I was solving this, I took cases in which there are 2 letters and then there are 3 letters, and then I kept arranging. So it took a while, but I got to the answer. And I didn't use this method again. So, like, how do I see a question and I realize that I need to use this method because I'm still not being able to catch it?
तो आपको उसका कॉम्प्लीमेंट देखना होता है कि कौन सा so basically it's always the probability of favorable cases and probability of unfavorable cases will always be 1 क्योंकि यहाँ तो कोई केस फेवरेबल होगा या अनफेवरेबल होगा राइट और तो कोई पॉसिबिलिटी है नहीं राइट
Right.
So favorable is separated by at least one letter. What's going to be unfavorable for you?
Right.
And they are together. So that's what you get. 1 minus P, they are together. So that's what you get probability of favorable, which is whatever you want. In this case, at least one letter.
Oh, okay.
So you can always see
Got
कि
it.
खासकर जब at least आता है या at most आता है, so you know कि you can look at the complement case and see whether that's easier.
I'll try it next time. Yeah, I'll try it first.
Any other doubts, questions here? Okay, let's do this one. Okay. So it says employees of a certain company are each to receive a unique 7-digit identification code consisting of the digits. So there will be 7-digit identification code, and these are also 7 digits, such that no digit is used more than once in any given code. So there will be no repetition. In valid codes, the second digit in the code is exactly twice the first digit. So there is a constraint on the first and the second digit. The second is exactly twice the first. Other digits, there are no constraints. Right? The other thing is, of course, there can be no repetition. Okay. So the second is exactly twice. So if you look at the numbers here, we are looking for numbers which have sort of their twice also there in the, because we need the second digit to be the twice the first digit. So the first digit can be, if the first digit is 0, then the second also needs to be 0. So, but there can be no repetition. The first can be 1. In that case, the second is 2. First can be 2, second will be 4. Third, 6. So that's all. First cannot be outside these. So there are only these 3 cases for the first and second. Right? Now for the remaining 5 digits, we can have 5, 4, 3, 2, 1 cases. Right? And because there are 5 digits remaining after you have consumed 2 here, so there can be 5, 4, 3, 2, 1 multiplied by, and sort of, or in other words, these many cases will be for this also, for this also, for this also. So overall 3 into this, which is 120. So overall 360 cases. Any questions, any doubts here?
Yes, I got it. But I initially took time to, after segregating these two steps, finding 3 into 5 factorial, that took a bit of time for me to click. So yeah.
Okay. So you could create the cases, 3 cases.
Yes. I could create the cases and I was sure of the 5 factorial number as well for each case. But yeah, the multiplication by 3 part took like a minute. I took a minute to get there.
Basically 5 factorial, or you could have also arrived at this, 5 factorial plus 5 factorial plus 5 factorial. 5
Yeah.
factorial इसके cases,
Yeah.
5 factorial इसके, then 5 factorial इसके.
Yeah.
Right. Any other questions? Okay, let's do this one. Okay. So there are 10 books on a shelf, of which 4 are paperback and 6 are hardbacks. How many possible selection of 5 books? We need to have a selection of 5 books, just combination. Contains at least 1 paperback and at least 1 hardback. So the first thing is, if there are 5 books, is it possible that it doesn't have any hardback?
No, it's
No,
not
sir.
possible.
Right? So that thing is already taken care of. There are only 4 paperbacks. So naturally, if you're picking 5 books, there will be definitely be one hardback. So the only thing that you need to ensure is that you are also picking one paperback when you're picking five books. So in how many possible selections? So you need essentially, so the only case that you don't want, so essentially this question is same as this question because this is in any case in short, right? So there are 10C5 total cases because you're picking 5 out of 10 out of 5 out of 10 books. What you don't want is there is absolutely no paperback. So essentially you end up picking all hardbacks, which is 5 out of 6. Right? So 10, 9, 8, 7, 6 by 5 factorial, which is 120. So this gives 6 minus 6. So 6 into 6, 36, 7 to 52 minus 6, which is 46. Okay, so all the cases minus those cases in which you don't have a paperback. Essentially, all the books you are selecting out of hardbacks. Anything not clear? Any questions? Any doubts here?
So I had a doubt. I
Yeah.
got this format, but what if there were, for example, 5 paperbacks? Then would we add the other case of no hardbacks?
Okay, so let's say, so let's change it to instead of 5, we can make it 6 also. You want to make it both 5 or you want to just change the number of books to 11?
Yeah, anything is fine. So just the case where the 4 wouldn't exist.
So let's say there are 11 books, 5 are paperbacks and 6 are hardbacks, and we need to have at least one of both,
Right.
right?
Yes.
So one is 11C5 is the total number of cases,
Yes.
right? Now what you
Yes.
don't, right? And so what you don't want is, let's say you you don't have a hardback, or you don't have a paperback, or you don't have both. Both is not possible, right?
Yeah. So
So yeah, so essentially what we don't want is 0 paperback or
and
0 hardback,
yes.
right?
Yes,
So you
sir.
subtract those. So 5C5 minus 6C5.
Yeah, so essentially you would take 5C5 plus 6C5 in a bracket, then subtract as a whole from 11C5, right?
And that's what you can do. Yeah.
Yeah.
5C5 is just one. So there is one case in which you end up picking all the paperbacks.
Yeah.
And then there are 6 ways in which you end
Yeah.
up picking all hardbacks. So you subtract those.
Sure. Okay, sir. Thank you. That was the only clarification.
Yeah. Anything else in this question? Okay, let's do this one. Another 30 seconds to go. Okay. So it says that the difference 942 minus 249. So these is a positive multiple of 7. Okay. Could be. So yeah, 42, 42, so 700, 693. Yeah, that's a multiple of 7, okay? If A, B, C are non-zero digits, so they are non-zero digits, how many 3-digit numbers A, B, C are possible such that difference A, B, C minus C, B, A. So what I observe is the second digit remains the same. The first and the third digits are flipped. So this is a positive multiple of 7. So how many numbers are possible such that this is a positive multiple of 7? So how do we figure out whether what is required to make it a multiple of 7? So one way is to first open the numbers in terms of the digits. So ABC can be written as 100A plus 10B plus C minus 100C minus 10B minus A. This is the number we are looking at. So I'm just opening them in terms of the digits. So what I get is 99A minus 99C. B just cancels out. Essentially, we have 99 common, so 11 into 9, A minus C. Now, this can be a multiple of 7 only if this is a multiple of 7. And A and C are non-zero digits. So essentially, we are dealing with digits here. So this is going to be a multiple of 7 only if A minus C is equal to 7. Right?
Yes, sir.
We are looking at a positive multiple of 7. Thus, we will not include the possibility of 0 here. Yeah, otherwise 0 could also be a multiple of 7, but here we are looking for a positive multiple of 7. So A minus C is equal to 7 is the case we are looking for. So how many such numbers are possible in which A and C are separated by 7? Okay. So we can start with 9 to right? So how many such numbers are possible? 8, 1, 7, 0. But we are dealing with non-zero digits. So this is ruled out. So these are the only two possibilities for A and C. Right? For A and C, these are
Yes, sir.
only two possible.
Yeah.
This is 9 and 2 and 8 and 1. We cannot even have 1 and 8 or 2 or 9 because it's A minus C is a positive multiple of 7. So it cannot even be a negative multiple of 7. So we are just left with these two possibilities. And B can take any of the 9 values. Why 9? Because we are dealing with non-zero and there can be repetitions. So it's not that B has to be different from A and C. B can be any of the 9 digits. So for both of these two cases, we can have 9 possibilities for P. So essentially we'll have 9 numbers here, 9 numbers here. So overall we'll have 18 such numbers. So 18 is the answer. Questions, confusions, doubts here?
Sir, why not like 9 and 2 के बीच में हम they there could be possibility of any number, so it's a non-zero. अच्छा ठीक है I got it कि zero नहीं आ सकता तो there are 9 possibilities, right sir?
Yeah.
Okay, thank you.
Any other questions, doubts here?
So initially I missed the non-zero digit part, and
Right.
also while trying to figure out what A, B, and C could be, I got pretty confused. Like I couldn't come to the like the formula that you used for 100A, 10B, and C. So yeah,
Right.
that was where I was getting confused on how to approach this question.
So you didn't know this, that we can convert numbers into these forms.
No, I knew that, but I just did not know that we could, that it didn't click that I should use this approach in this question.
Okay, I see. Anybody who didn't use this, open these numbers up and still could solve it? Is there anyone who didn't use this and still could solve this question?
I didn't use this and I was trying to solve it without this. So it's a very lengthy, long process to find the multiples of 7, starting from 100 till 999. So I don't know why it didn't strike me, this 100A+10, because even I've solved so many questions, yet I could not think very clearly कि ये इसको split करके you will come to, did not
Yeah.
how do I put it? Like analyze the question only properly, and I just started solving it. So वहाँ पे it
Yeah.
was a mistake. Yeah.
Yep. Yep. Okay. Okay. Let's look at this one. Okay. Hmm. Okay. Well, Akansha, how did you do it?
So, I initially thought of the cases where the sum of two numbers would be 10, but then I realized that that is not the best strategy to go about this question. Um, because I read the question again that asks how many must be drawn to ensure that the numbers on two of the slips will have a sum of 10. So, taking the worst case scenario, if you take out the first slip and it's 0, then you'd have to take out another one, which also I'll take it as a worst case scenario of 1. Then the third one would be 2, which would still not add up. Then 3, 4. So now what I thought was I ended at 4 because the sum of 1, 2, 3, 4, all of it amounts to 10,
Right.
right? So that is how I ended my question. But and I sent the answer to you that you need at least 5. But then I reread the prompt again now and I noticed that two of the slips drawn out should have a sum of 10. So I would probably go ahead and put a 5 uh, and a 6 as well in it. And my answer would be 7 then.
Okay. Hmm. Others?
Yes, CJ, I would like to share how did I solve this. So
Hmm.
basically, like out of those five, sorry, from 0, 1, 2, 3, 4, 5. So these are like 6 numbers. I mean, if we get these 6 numbers with other number, we cannot get more than 10 or a sum of 10. So, I mean, these 6 uh, any combination with these 6 will not give us. So any number come after that 6 or 7 or 8, then we'll get a sum of 10. So
Yeah.
probably the answer would be 6 plus 1 7. So 7 would be the answer.
Yeah. Yeah. Okay. So Abhishek, how did you do it?
Sir, they said two of the slips drawn must will have the sum of 10. So we are drawing two slips and it should have a sum of 10. So I just did key 1 plus 9 is if we are drawing 1 and there's another 9, so it's a sum total of 10. Then 2 plus 8, and 3 plus 7, and 4 plus 6. Uh, that's all because इसके बाद 5 plus 5 we can't because we can't repeat and these are the only 4
Right.
pieces.
Right.
Yeah.
Okay. So do you see your answer is different from the other answers here?
Yeah, I see that.
So so you would so you disagree with what they are doing?
यस सर मतलब मुझे ऐसा लग रहा है कि जैसे टू ऑफ द स्लिप्स तो क्वेश्चन ये कह रहा है कि द नंबर्स ऑन द टू ऑफ द स्लिप ड्रॉन विल हैव द सम ऑफ 10 कि दो स्लिप्स ड्रॉ कर रहे हैं हम
Right.
उनका टोटल 10 हो रहा है
Right.
तो आई थिंक दिस इज द बेस्ट वे टू डू इट
Hmm. क्वेश्चन क्या है हमारे पास? What does the question say?
वी हैव 10 इंटीजर्स एंड
सब तो हो गया and if we are picking one slip at a time without replacement यहाँ तक तो it's fine.
यस
ये इसका क्या मतलब है यहाँ से लेकर यहाँ तक?
how many must be drawn to ensure that the number of numbers on two of the slips drawn will have the sum of 10.
राइट।
मैंने मतलब कितने ड्रॉ करने पड़ेंगे टू इंश्योर दैट।
कितने क्या ड्रॉ करने पड़ेंगे? हाउ मेनी क्या क्या ड्रॉ करने पड़ेंगे?
टू ऑफ द स्लिप्स सर की मतलब सेट ऑफ स्लिप्स, टू सेट ऑफ स्लिप।
वो तो आगे लिखा हुआ है, यहाँ का मतलब पूछ रहा हूँ मैं। हाउ मेनी क्या स्लिप्स, क्या हाउ मेनी है?
स्लिप्स के बारे में ही बात कर रहे
हाउ मेनी स्लिप्स मस्ट बी ड्रॉन, ये कह रहे हो?
सर। यस सर।
तो अभी हमें पता नहीं है कि हम 2 ड्रॉ कर रहे हैं, कितने ड्रॉ कर रहे हैं, ये कह रहे हो?
यस सर। मतलब हमें अभी पता नहीं है कि हमें ड्रॉ क्या करना है, ड्रॉन टू इंश्योर दैट स्लिप्स ड्रॉ
नहीं,
करनी है, दैट्स वी नो
नहीं,
दैट।
कितनी स्लिप्स ड्रॉ करनी है ये नहीं पता हमें।
यस सर।
तो हमें हमसे पूछा जा रहा है कितनी स्लिप्स ड्रॉ करें।
करें कि दो स्लिप्स का जब आंसर 10 बनना चाहिए, सम 10 बनना चाहिए।
उनमें से कौन सी 2 स्लिप्स का, जो पहली
जो
2 की थी या लास्ट 2 पिक करी है? Just give me a moment. या कौन सी 2 स्लिप्स का सम 10 होना चाहिए?
सर जो हम ड्रॉ करेंगे।
हमने 2 ही ड्रॉ करी हैं।
नहीं सर, हमने दो नहीं ड्रॉ की, हमने की तो 8 हैं।
8 ड्रॉ करी हैं हमने।
सर जैसे 1 + 9, 1 एक अलग होगा, 9 एक अलग होगी।
नहीं, वो तो आप सोच रहे हो।
हम्म।
क्वेश्चन पूछा जा रहा है कि कितनी ड्रॉ, क्वेश्चन की बात कर रहे हैं, वो तो आप आंसर पे जा रहे हो कि हमने 8 ड्रॉ करी हैं कितनी, तो आप
हम्म।
आंसर 8 कह रहे हो।
सर आई एम सेइंग कि एक सेट में दो हैं।
तो हमने कितने सेट्स ड्रॉ करे हैं ये पूछ रहे हैं कुछ।
नंबर्स ऑन टू ऑफ द स्लिप्स सर, कि नंबर्स पूछ रहे हैं ना कि द नंबर्स ऑन टू ऑफ द स्लिप्स ड्रॉन विल हैव सम ऑफ 10।
क्वेश्चन क्या पूछा गया है, हाउ मेनी क्या सेट्स, हाउ मेनी सेट्स विल गिव यू अ सम ऑफ 10, ये पूछ रहे हैं क्वेश्चन।
यस सर।
अच्छा, तो यहाँ पे हाउ मेनी सेट्स है, ये कह रहे हो आप?
इस सेट्स तो मतलब मुझे जो लग रहा है कि हाउ मेनी मस्ट बी ड्रॉन टू इंश्योर दैट द नंबर्स ऑन टू ऑफ द स्लिप्स ड्रॉन मस्ट विल हैव सम ऑफ 10।
हाउ मेनी क्या मच बी ड्रॉन, वही तो पूछ रहा हूँ मैं आपसे। आप पहले कह रहे थे स्लिप्स, नाउ यू आर सेइंग सेट्स। तो
ना कंफ्यूज।
चलो ठीक है, तो जो भी मान लेते हैं, अगर सेट्स भी मान लेते हैं, वो सेट्स कह रहा है हाउ मेनी सेट्स मस्ट बी ड्रॉन टू इंश्योर, इसका क्या मतलब है?
सर ड्रॉन ड्रॉन टू इंश्योर मतलब कि निकालना है।
हाँ, ड्रॉन करना है टू इंश्योर दिस हैपेंस, राइट।
दिस हैपेंस, यस सर।
तो ये तो हमने 1 और 9 निकाल लिया, तो दिस हैज हैपेंड, नहीं हमें बाकी क्यों निकालने की जरूरत है? इफ आई पिक आउट 1 and 9, द सम इज 10।
यस सर।
So how many sets must be drawn? Only one set. 1 and 9. I'm done.
Yes, sir.
तो फिर बाकी क्यों बोल रहे हो? तो the problem is at multiple levels. एक तो comprehension तो clear है ही नहीं वहाँ पे कि what is the question asking. So the mind just goes into creating cases. It of course it is not creating cases कि किसका multiple 10 आ रहा है, किसका multiple 6 आ रहा है. Of course it is not completely random, but it is almost random. Just using the same words or just picking bits and pieces of the question. तो आपका दिमाग केसेस बना रहा है कि अच्छा किस में 10 आएगा. वो किसी ने पूछा नहीं है कितने केसेस में 10 आएगा सामने. The question is very different. But this is what is happening inside the mind.
Okay, sir.
ठीक है. So that is where the problem is. Of course, एक तो है कि you have not understood the question. The second is you don't have an inkling, you don't have an idea कि ऐसे नहीं समझ आया है. तो वो mind just solve करने निकल पड़ा है. Even though, so that's what I was trying to sort of make you stop at the words to really see. Because if you really pay attention to the each of the words, you will see that you cannot justify कि वो words वहाँ पे क्या कर रहे हैं, given the meaning that you have in your head. So unless you do that, really you can justify कि हर word you understand कि वहाँ पे क्या कर रहा है. It's entirely possible the ideas that you have in your mind may be completely different from the what is being asked, and that's what the case here. वो क्वेश्चन ये पूछ नहीं रहा है वो बिल्कुल भी. पूछ रहा है कि how many slips, क्योंकि वो पहले if part is slips. If the slips are then drawn one at a time, how many must be drawn? So it is talking about how many slips must be drawn. कितनी स्लिप्स ड्रॉ करनी पड़ेंगी इंश्योर करने के लिए कि नंबर ऑफ 2 ऑफ द स्लिप्स विल हैव अ सम ऑफ 10. तो किसी ना किसी का कोई भी 2 का सम हमारा 10 हो जाए. इंश्योर करना है हमें. ऑफ कोर्स एक पॉसिबिलिटी तो है कि पहले आप 6 पकड़ो दूसरी या 4 आ जाए. तब तो 2 ही स्लिप्स में आपका काम हो गया. यू आर डन. बट दिस मे नॉट हैपन and you want to ensure that the number on 2 of the slips will have a sum of 10. So you have to think of the worst case. Your worst case may be मेरा ये ऐसा हो जाए. So that's why other people here were talking about the worst case कि अगर शुरुआत में 0 से भी शुरू होती है फिर 1 2 3 4 5 आता है. Even after 6 slips, I don't have any 2 slips जिनका sum is 10. So when I add the 6th, 7th slip here, then definitely the sum of 2 of the slips will be 10. क्योंकि या तो मैं 6 करूंगा या 7 करूंगा या 8 करूंगा 9 करूंगा. ये सब ही किसी ना किसी के साथ पेयर बना के 10 बना देंगे. So you need a minimum of 7 slips to ensure that the number on 2 of the slips will have a sum of 10. Does that make sense?
Yes, sir.
Okay. Okay. So let's do this one. This one may be our last question for today. Okay. So there are two ways to think about this. So we are looking for 3-digit integers greater than 700. How many have 2 digits that are equal to each other and the remaining digit different from? So what we don't want is all 3 are same or all 3 are distinct, right? So we need 2 to be same and the third to be different, right? But if you think about it, there are just 3 possibilities, all 3 different, all 3 different, or 2 same, 1 different, all 3 same. These are the only 3 possibilities. There is no other possibility, right?
Yes, sir. Yep.
So you can use this understanding because we are looking at numbers greater than 700. So we're looking at 701 to 999. So we're looking at 299 numbers, right? So out of these 299 numbers, you can subtract all 3 different and all 3 same. You'll arrive at this. So how many numbers will have all 3 different digits? So the first digit can be 7, 8, or 9, 3 possibilities, right? And the remaining 2 could be anything.
Yeah.
Right? This is all 3 different. The first could be 7, 8, 9. And the second digit could be all except that. And the third is all except the first 2. And then we have all 3 same. So all 3 same is pretty simple. Just 3. Right? So out of 299, you have all 3 different minus all 3 same. So you get 80. So these must be 2 same and 1 different. So that is the answer. Okay, another ways you can directly think of 2 same, which is going to be a little complicated, but essentially, if you want to keep 2 same, you can keep the 100 digit as one of the 2 same, right? So if you keep 100 digit as one of the 2 same, essentially you are saying something like 7, and then you have 7 in the second place or the third place. So let's say if you have 7 in the second place, then you have 9 possibilities here. Why 9? Because you cannot have 7. Third digit cannot be same. So you can
Yeah.
have 4, 5, 6, 8, 9. 9 such possibilities. Or you can have 7 here and 7 here. And then again, 9 such possibilities here. This is the case in which you are keeping the 100 digits, this 100 digit as one of the one that is the same. Or you can have 2 different same. So 11, 22, so on, 99. These are, you can of course have 0, 0 also. So now in this case, in case of 7, you need to eliminate 77 and 0, 0. So there are 8 here, 9 possibilities here, 9 here. So overall, there are 26 possibilities with numbers starting with 7. For numbers starting with 8 or 800s, you'll have 9 possibilities here, 9 here, and 9 here because 800 is valid number. Okay, so in case of 800s, you will have 27 such possibilities. So 26 these possibilities plus 800. Similarly, for 900s also, you will have 27 possibilities in which 2 digits are the same and 1 digit is different. So again, if you add them up, 26 plus 27 plus 27, you arrive at 8. Anything? Yeah.
So I was trying to do it initially with the first second method that you told me, but I got very confused while doing the calculation and structuring it. That's why then I thought of another way, which was the first method that you did.
Yeah.
And so yeah, while like now that you said it, I understand it. But in like while doing a similar question later on, I think I would still get a little confused if I took this approach. So will the solution to that be to really analyze it first? Because I couldn't understand this approach as fast as you did. Like after reading, I wouldn't be able to do it like in a split second like you did. I would have to put like a minute's worth of thought to get to the process that you are doing.
I would also take it's so the way I explain, of course, it's I've already thought through it. It's not that the first time I'll be this fast.
Okay.
Okay, this will
Okay.
take some time that you
Yeah.
are trying to understand. Okay, let's keep the 100 digit as one of the same digit, or let's keep it the different digit. These are the cases you need to think through, and then you also need to make sure that you're not missing anything or you're not double counting. These are essentially the two mistakes. Undercounting,
Right.
overcounting. Overcounting essentially you're double counting some of the cases, or you're counting some of the cases which don't satisfy the constraints.
Right.
Undercounting is you are ignoring the valid cases. So you have to make sure these two things happen. So it will take some time.
Yeah.
So
Okay.
again, so yeah, so this is the time consuming. This will get you the answer, but so that's why I started with the first one. That's a more efficient way. Okay, and that
Right. Yeah.
happens in permutation combination. That not just permutation in all the quant concepts. There is there are multiple ways to solve, and some ways are much more efficient than other ways.
Right. Got it.
Any questions? Any doubts? I don't think we ended up uh, sort of addressing or having questions around permutation or the confusion around permutation combination, uh, which is the common problem that was asked. We had a question on 1 minus favorable case or unfavorable cases that we did. But so yeah, I don't think we had questions exploiting confusion between permutation and combination. So I would say that if you come across such questions which are confusing to you, then you can sort of collate them and then we can pick up in one of the upcoming sessions. Okay. Yeah, and similarly for probability also. So that was one of the things mentioned here. So if you have questions which are confusing and what aspect is confusing, if you can just share that in the general thread there. So that will give me some ideas on sort of what to focus on in the session. I was just taking questions that are more popular on GMAT Club, sort of which are confusing for a lot of people. But I could see that many of you were getting the answers right. So I'm not sure whether I was really able to hit those confusing areas for you. Okay. So in the next session, possibly if you can share your doubts, all of you, or regarding permutation, combination, and probability in the journal thread. I can just focus on those questions and similar kinds of questions in the next session.
Okay. Sure, sir. We can do that.
Cool. Anything else you want to ask, say, before we leave?
So I think question types other than this that we have in permutation and combination, which might not be like the conventional ones that we've done today, that is where I would face a lot of errors. So I'll try to find if I come across any of these questions in this week, and
So
I'll
those
put in
will
it today.
always exist. Okay.
Okay.
Again, so it may not be very helpful is to just focus on fringe cases. Of course, you will always keep having problems in some of the questions. But is
Hmm.
that really the main area that you should be investing your time in? That's an open question.
Hmm.
Okay, a lot of people actually invest a lot of time worrying about very hard questions because you just can't get a
Yeah.
hold on.
Yeah.
But even if you don't solve, you don't get any very hard question right, still you can hit a 90th percentile on quant. You don't
Hmm.
need to worry about, or let's say not 90th, at least 85th percentile on quant. So you're unnecessarily wasting your time on very hard question, even though you may be getting medium and hard questions wrong.
Hmm.
Right? So it makes sense to, of course, some fringe cases could be relevant that some aspects of them could be coming in various other questions. But if some question is very unique, you can just learn from it to whatever extent you can and then move on.
Got it. Got it.
Yeah.
Would
So-
you say so? Sorry, yeah, Riya, go ahead.
Good.
So would you say that the questions that we've covered today are like the basics that we need to be very sure about, or are there more concepts in PNC that we need to master, like
This is
master?
not around any specific basics. I was just, so essentially, I was picking questions that were more popular on GMAT Club.
Okay.
Okay. So that, again, some of the questions were actually very hard also.
Yeah. Okay. Yeah, Riya, you can go ahead now.
Thank you. So very helpful session. I could not do last 3-4 questions. So
Okay.
I understood my mistakes.
I see.
Yeah, so this was helpful. Initial questions I was able to do, but later on it started getting complicated for me. Yeah.
Okay. I see. Okay. Thank you.
So that comprehension part, how many the slips one.
Right.
My reading was wrong in that question.
I see.
Yeah.
Okay.
CJ, in my case, I got incorrect question in very easy question
I see.
because I took it very lightly, or maybe I got confused initially. But
Okay.
yes, I got this lesson that not an one shouldn't take any question lightly, because it happens in these cases when we miss one of the scenario, our
Yeah.
whole answer will get changed. So that
Yeah.
was my learning, because I also misread that P and E. So that was very
Okay.
unusual. I mean, I made mistakes in very easy questions. So
Right. Right.
yeah, I'll remember this. Thank you,
Okay.
CJ. Thank you.
Yep. Thank you. Okay. Anything else?
So is it possible that we could have more frequent sessions rather than once in a week? If you have the bandwidth and not no compulsion. But yeah.
Yeah. We'll no, I think we'll have a session over the weekend. I would want it to not be over the weekend, so that because my weekends are very packed. It was a packed day
Mm.
today, but I can understand a lot of people sort of have their schedules in the weekdays. But yeah, so we have I think 6 more sessions as part of this cohort. So we'll cover them for the next 6 weekends. Okay.
Yeah, so I was suggesting maybe Saturday and Sunday, both days.
I need both days are for me, even one session is a challenge. Both days.
No worries. You're taking out time. That's the biggest thing. Yeah. Thank you, sir.
Yep. Thank you. Okay. Take care.
Thank you, sir.
Bye. Good night.
Thank you.
Thank you, sir.
Bye bye.
Thank
Yeah.
you, sir.
Thank you,
Thank you,
sir.
sir.